the Focus on Geothermal webinar series. Again, this is a collaboration between ThinkJ Energy and Enerchange. I am Carlo Cariaga, Editor-in-Chief of ThinkJ Energy, and today we have the honor of hosting Ali Yetkin, who is a Senior Exploration and Wellsite Geologist from the Sanko Energy and Production Company in Turkey. He is an expert in wellsite geology and exploration with 10 years of experience across geothermal and oil and gas. Yetkin holds a Master's in Science in Geodynamics from the Eurasia Institute of Earth Sciences, and his work centers on the provenance of pre-Jurassic basement units in the Sakarya zone. His professional career includes a decade of managing drilling data and geological evaluations as wellsite geologist and mudlogger. So today we are going to talk about the use of p-XRF or portable X-ray fluorescence and geological observations for geothermal exploration and also geothermal drilling. So p-XRF can be a very useful tool for identifying, say, hydrothermal alteration or lithological boundaries during drilling. Perhaps improving work processes in exploration and also better drilling or better targeted in drilling. But I shall let Yetkin explain this in better detail. Yetkin, you have the floor.
Hi. Hi, everyone. My name is Yetkin. I'm working as a senior geologist for Sanko Energy company. I have 10 years experience on wellsite geology and exploration geology, as Carlos said already. Okay.
Sorry, Yetkin, just to interrupt a bit. For the audience, you can type in your questions at any point. There should be a questions tab somewhere in your webinar panel. So just send in your questions at any time and we'll get to them after the presentation. Yetkin.
After the presentation is better. Can you hear me, Carl?
Yes, go ahead.
All right, okay, thank you. Hi again. This presentation was prepared by Deniz Özbek and me. Deniz focus on the controlling XRF data and interpretation. I should also mention that his work hasn't fully begun yet. I focus on the contribution of XRF data with wellsite and exploration geology. Today we will share early insights into the project, and if we have time, we will talk about the project's other targets. First of all, I shortly talk about my company, Sanko Energy company, focus on green energy. So their portfolio made of 6 hydroelectric, 3 wind, 3 hybrid, and 3 geothermal power plants. Geothermal power plants are located in Salihli town. Salihli is located western part of Turkey. Technical steps of presentation. Before the presentation, I should share technical steps of presentation. First, we talk about regional geology. Otherwise, the information to be shared but may not be clear. Secondly, we discuss the characteristic of p-XRF and the difference from the traditional XRF. Thirdly, we should talk about wellsite geology because wellsite geologists are first witness of the sample and well operation. After that, we will contribute to p-XRF wellsite geology and drilling operations. All our discussions up to this point have been based on observation. After the second part, our presentation focus on exploration methodologies and p-XRF effects. Regional geology, Salih Basin. Salih Basin is a part of the Gediz Graben, and Gediz Graben part of the Western Anatolia. It's half graben, also. Sorry. The Salih Basin part of the Gediz Graben, I already said that Gediz Graben is a structure formed by the extensional tectonics in north to south direction. This region now experienced convergent movement during the paleotectonic period, while active tectonic periods were shaped by divergent movements. Therefore, the Menderes metamorphic, which is constitute our bedrock, exhibits prograde metamorphism. The heat source mechanism, as in other Western Anatolian geothermal structures, relies on thin crust and mantle uplift. However, our reservoir is not dependent on the karstic discontinuities in marble or limestone. As in other Western Anatolian geothermal systems, our reservoir based on fault and large fracture system caused by these faults. So, what is important for us is the faults and their relationship with each other. Therefore, p-XRF gets more important for our basin. Mendel's metamorphics providing a unique structural setting for high enthalpy for geothermal system. For example, our highest temperature geothermal well shows 308 Celsius. Probably we will pass this. Also, we have three sedimentary formations in the area. Our sedimentary formations, all of them is autochthonous and made in continental deposition environment. Our detachment fault locates south side and it's aimed to north. Also, we have two different fault systems. One of them is west to east direction. They are normal faults. And north to south directions are structural faults. Now we can enter the p-XRF technology. Firstly, let's look at the difference between two devices. Portable XRF use energy dispersive technology, but laboratory XRF wavelength dispersive technology. Also, their detection principle is a little bit different. Portable XRF use a single detector to sort X-rays by energy levels. Laboratory XRF use crystal to diffract X-ray by wavelength for higher resolution. Also, portable XRF can work ambient air under the atmospheric conditions, but laboratory XRF needs vacuum environment. Speed is so important for drilling operation. Portable XRF analyze duration 15 seconds to 90 seconds, but laboratory XRF slower. Needs some minutes for analysis and also hours for preparation. So, both of them give us quantitative data. Of course, laboratory XRF little bit strong in this place. Firstly, the wellsite geologists should check cuttings and approve the sample for the p-XRF process because sometimes geological samples mix the sample. So every time wellsite geologists check these cuttings. The operator also must be careful during the washing and drying stage of samples because of mud and humidity problems. After that, you can see the analysis process photos. First, the sample needs to be ground and then sifted. Afterwards, the remaining material is placed in a container and compacted. Finally, it placed on the stand. So this device gives us data via TXT file format. After that, we pass to the Excel file for interpretation. Now we solve chemical interval analysis. This basic analysis, firstly you solve first graphic major oxide. Second graphic shows trace elements. Third one alteration index, and fourth shows potassium oxide, aluminum oxide ratios, lithology ratios. It's made four different intervals. First interval is Agidere, about Agidere formation. Agidere is our lowest sedimentary formation in our area. uh, characterized by silicium oxide and aluminum oxide. This is a typical geochemical signature for a classic sedimentary sequence specific alternating claystone and sandstone. The second interval is detachment fault site. The major transition mentioned is mathematically evidenced by a sharp spike calcium oxide. You can see here the red line increase, and the blue one is silicium oxide decrease in this place. The calcium concentration surge from approximately 5% to over 22%. The third interval is basement, fillet and marble, fillet and marble. So we use uh, potassium oxide and aluminum oxide ratio collaborates transition into fillet and mica schist. Just mica schist is not enough. Biotic schist, mica schist, and muscovic schist we observed. And last interval after a start from the 36, 50 meters quartz dominance level, and it creates some problem for interpretation. We will touch them next. Okay, now hydrothermal history. As you see, now, this time our intervals count 6. First one is start 2400 to 3100. Its formation Acıdere is argillic, zone, alteration zone is argillic, stable aluminum oxide and silicium oxide, and low AI. AI meaning alteration index. Alteration index lower than 55. Also estimated temperature. It gives us 120 to 180. All of these data, all of these interpretations can doing thanks to p-XRF data. For example, we can look fourth column, 3197 meters to 3250 meters. Its detachment fault zone, phyllic and carbonate alteration zone is phyllic and carbonated. Extreme calcium oxide spike we observed, higher SR and barium. The estimated temperature is 250 to 300. How can we estimate temperature? Because of the alteration type and alterated minerals give this information for us. Let's move. The other one, Ishikawa alteration index. It's important for us. As you can see, we have different type alteration intervals. How can we categorize this alteration index? Low alteration index, it's meaning smaller than 50 points. Alteration index, it's meaning low. If our alteration index between 50 to 70, it's moderate hydrothermal. It's meaning moderate hydrothermal activation. High hydrothermal alteration is stay between 70 to 85. And also intense core reservoir AI point bigger than 85. Okay, how can we use p-XRF for confirmation the observation? Our observation during our all drilling operations revealed two distinct levels for Acıdere formation, the upper part and lower part. Upper part of Acıdere exhibit moderate consolidation, high water interaction, fracture healing, and matrix supported, and etc. The lower part of Acıdere shows good consolidation, low to very low water interaction, lack of fracture healing, very weak and very weak mineral lineation, and some textural difference. We also know that the lower part of Acıdere has exposed high temperatures. Therefore, we used to say lower part of Acıdere, it looked like brick. Incidentally, I should add that there are many brick factories in the Salih region, and they obtain their raw materials from the clays of the Acıdere formations. For these reasons, we were considering whether the lower level of Acıdere might be anchimetamorphic, and after that, we conduct experiment to determine if we could answer this question using p-XRF data. Mineralogical maturation, finding significant rise, potassium oxide bigger than 2.5%, and strong linear correlation with aluminum oxide between 3100 to 3200. Indicate increased elite crystallinity and the permanent fixation of potassium with the clay lattice. Also, alteration, we check alteration chemistry, base leaching. Finding is calcium oxide and decline, and magnesium oxide and potassium oxide sum is increased. Sorry about my phone. Stop. Results of the Iskaba index shifts from 40 to 50 to consistent 55 to 65 range. Upper side of Acıdere shows 40 to 50, but lower Acıdere shows 55 to 65 and generally close to 65. This confirmed the mobilization of alkali elements cooking as the sedimentary sequence enters the metamorphic transition window. And also tectonic compaction and immobile elements we use for this, stable time oxide and aluminum oxide ratios paired with silicium oxide fluctuations. This reflects anchimetamorphic loading and tectonic compaction, where mineralogical reorganization begins as poor fluids are expelled. And last one is thermal regimes. Its temperature ambient range 150 to 200 Celsius. Also, we generate alternative wellsite techniques with p-XRF. It's my other favorite determination. If we're sure that the sample has been properly washed, also we can easily observe an increase in amount of the lignin chemicals in the analysis. The levels where these increase may provide depths of the microfracture structure. Difficult to observe the mud loss in the well-consolidated sample if our level made of content clay, it's better for this technique. For example, as you can see, it's calcium oxide, this red line again, calcium oxide is picking up and silicium oxide down. So we saw this one, and we know low-level partial mud loss observed at this depth. But generally, low-level partial mud loss are often overlooked and considered surface losses, because evaporation, shaker system, or mud pit lines problems can be cause this. However, thanks to the small amount of mud loss, we can infer that we are approaching a potential target. How? Because our mud fill the cracks. Also, clay and mud loss get in reaction. After that, when we use p-XRF, we saw mud chemicals in our sample. But upper side or downside samples never contain mud chemicals. So we checked our samples again, and we find calcite veins in the fractures. So it's explained why calcium oxide rating increase at this level. So it can use for determining new possible reservoir or faults, or you can use for this for we are getting close to our targets or not. It's help. Also, I can show you a seismic cross-section. Here is our fracture zone, and we observe all these that are mud chemicals in the sample, quantitative sample. Limitation of p-XRF analysis. XRF cannot distinguish the cement contaminating the samples, so we shouldn't use immediately after the casing cementing operation these tools, or cannot distinguish the drill mud contaminating the samples, but we have this information, so we always think mud chemistry when we try to interpretation of XRF data. Also, XRF cannot identify cracking materials and main formation materials. If we drill a huge quartz schist vein, XRF of course cannot understand it and think that it's a formation, but no, and we will see its effect on interpretation. Also, XRF provides only raw data. Proper interpretation requires fundamental geochemical knowledge, and this problem can be solved with trained artificial intelligence models. I think it's near future. Also, I shortly talk about wellsite geologist work because they are so important for drilling operation. Wellsite geologists have some tools and techniques. Also, mud logging service is very important for us. Real-time, because mud logging provide real-time drilling parameters, sample connection to that because of the lag time, and provide gas observation. Geologists use microscope tweezer, ACL, and their experiments and geological backgrounds. And also, if the researcher team shares interpreted seismic cross-sections, sometimes they don't want. I don't know. p-XRF should be added as another tool for them. Why p-XRF should be used by wellsite geologists? Direct on-site supervision of XRF interpretation by geologists, monitoring potential errors inherent to XRF analysis, cross-verification of geological observation throughout the XRF dataset, requirement for the expert capable of the interpreting XRF data, presence of a supervisor to monitor the sample origin and preparation stage, identification of anomalies such as calcite vein, quartz vein, etc., and also elimination of the effects of drilling materials like drilling mud, for example. Contribution of the p-XRF to wellsite geology. If you Google p-XRF benefits for wellsite geology, you will see these three titles: formation and drill bit harmony, caving or tight hole risk, casing set depth. But these are risky for, of course, caving or tight hole risk are risk for drilling operation, or casing set depth are important. But experienced wellsite geologists easily detect these problems and features. Also, drilling system based on solving these type problems. If we do not work on a highly risky region, we don't need the p-XRF just for these duties. We should use the p-XRF device for more duties. For example, detection of potassium changes, detection of calcium losses, or detection of magnesium changes. Why? Because geologists can use p-XRF data for target and survey relation, or it's able to track hydrothermal alteration signs via p-XRF data. One can understand edit crystallization because it gives us antizone, epizone. I give experience. I share experience already about antizone. Also, for example, arsenic is increase, sulfur increase. It means fault or fracture zone, or we are closing fault or fracture zones. SP high and Hg high, it means shallow system, epithermal system. Or CO2 high, but zirconium is stable, it means hydrothermal, strong hydrothermal activity, and quartz vein very close. Misinterpretation of p-XRF data. Also, it's a risk for wellsite geologists, and I should share with you. For example, our last row shows it's an example for this. Low sulfur and CO2 is high, especially rationally CO2 and zircon ratios increase 6,600 more than. At end of this, if we just look silicium oxide and zircon, we can say this silicification it means quartz rate. But we know that Menderes metamorphics upper sides of Menderes metamorphics contain lots of quartz lands. So we ask if this structure made quartz vein, where is this sulfur? Because hydrothermal activity also increased sulfur ratios, but we know that sulfur is low in the same depth. So it shows that, of course, wellsite operation needs p-XRF, but p-XRF data also need wellsite observation. Otherwise, it creates some problems. We observe a huge quartz wave and we think that we are getting close, but maybe it's not. So far, we have made assessment based on our observation and initial findings. From now on, we will discuss the areas where we anticipate improvement. Exploration geologists need some data. Geological data, field observation, tectonic survey, geomorphology, or etc. Also, they need geophysical data, seismic data, MT, gravity and magnetics. MT is meaning magnetotelluric. Also, geochemical data are important for exploration. Geologists, geochemistry of natural springs, for example, or fumarole, and etc. Exploration geologists also they should use some programs, Petrel, Kingdom, ArcGIS, QGIS, CSI, Global Mapper, or R for geochemical analysis. And exploration geologists should combine and correlate all data. Why? Because, for example, tectonic movement change geophysical interpretation. If we work in divergent movement effect area, we shouldn't draw reverse fault, for example. Also, geochemical evidence affect interpretation of structural geology, and lithological condition change hydrothermal targets. How can change hydrothermal targets? For example, we reach the fault surface, but our lithology is metaschist. Metaschist is very bad lithology for reservoir capacity. So, if we can estimate our lithology, it creates huge effect on us. p-XRF can provide answer to some important questions at this point. All data provide new strong and quantitative evidence. Which type structure has the more effective reservoir condition? How affect at this? For example, our alteration minerals give us low temperature. It means our reservoir is cool and not give us enough potential, hydrothermal potential. So we can change our reservoir structures. Estimation to fluid flow and heat flow directions. We can use p-XRF data interpretation for this, but we need more than one wells data. Otherwise, it's too hard and contain too much faults. Also, we can use hydrothermal fluid pathways and feeding zone. How? Again, same thing, alteration minerals and their conditions. Early findings with p-XRF. When integrated with wellsite geological data, p-XRF provide critical information for decision making. While not mandatory for every routine drilling operation, but p-XRF should be used systematically. For example, during exploration drilling, wildcat wells drilling, or drilling targeted if we target the new and different reservoir, we should use p-XRF. Also, we can use for this tool optimize operation costs and shorten the time to reach the target. How? For example, p-XRF data, he provide us where is the reservoir. How? If start, for example, CO2 increase, sulfur increase, we can say that, oh, we are getting close to possible reservoir. Also, the p-XRF can use for a highly risky drilling place for caving or other things. Further, the studies aim at characterizing the heat source throughout element signatures, delineating the relationship between thermal anomalies and structural contours can be used, modeling fluid flow pathways in reaction to structural permeability. Maybe we can construct a map, fluid flow maps or heat flow maps with this, enhancing reliability of target detection and reservoir localization. And it's my dream, actually, p-XRF and wellsite data collaborate with MT and gravity magnetic data, especially MT, because of MT shows alteration regions as. Our other main objective is to create a sufficient large dataset using new p-XRF data obtained from both in our region and elsewhere. This will allow us to generate real-time, high-performance quantitative data for exploration geology phase, wellsite geology phase, or reservoir studies. Thank you for listening. I hope speak understandable.
Thank you, Yetkin. That was a lot. Like, that was a very good presentation. We have a couple of questions here, but I'm also going to get started with my own questions. Okay. In one of your earlier slides, you summarized the difference between p-XRF and lab XRF, and there was a mention that lab XRF had better
Yeah.
resolution. So has there been a study done comparing the results of these two methods, and is there a significant difference?
Sorry, can you ask
Sorry,
again? I don't understand.
has there been a study done comparing results of analysis using p-XRF and laboratory XRF using the same sample set? And
Uh,
is there a significant difference?
for now, we didn't do this because we know that portable XRF give us enough results. There, yeah, laboratory XRF maybe we will use next stage of this project. I don't know.
Okay then. For those in the audience, you can still send in your questions. Just feel free to send them in, and then we'll get to them later on. Let's go to some of the more practical aspects of using a p-XRF detector or measurement for during wellsite geology. You mentioned that it's not able to differentiate the signature of drilling mud, right? What
Yeah.
is that part of the treatment of the cuttings? Is there any washing that you do before analysis?
Yeah, wash process is important because if operator use, for example, how can I say, few water, it creates also problem. So always sample washed same technique and same amount of water. After that, it's cooking part is important, not cooking. It's and humidity process is important. Otherwise, this time water chemistry creates some problems. But we know that during the drilling, our operator is expert and always washed samples the same. And
Okay, sorry, go ahead.
can you ask again? I think I can't answer your question. I couldn't answer.
Okay, I have two follow-up questions regarding that. During
Uh-huh.
washing, is there a risk that, say, if you're still drilling through the elite layer or smectite layer, is there a risk that you're losing some of the clay from the cuttings?
Yes, it's always happening, but it's tolerated. We don't have any chance. We always lost clay,
Okay, then. So
unfortunately.
I mean, that's just part of the analysis, I suppose.
Yeah, this is not just for p-XRF problem, also wellsite geologist problem at the same time.
Okay. Yeah, of course. Okay, then. What is the time it takes for, say, between collecting the drillings, drying, washing, and grinding, and analysis? How long does it take between collection of the cuttings and then the analysis and p-XRF?
Yeah, so it takes not too much time, but preparing process can take few times. Uh, if well organized p-XRF system, if well organized, they can did 60, nearly 60 or 50 analyzes at the day. So, for example, if we collect sample every 5 meters, we can choose uh, every 10 minutes, sorry, not minutes, every 10 meters samples can using for p-XRF. It's easily compare.
Okay, okay. A few questions here from the audience. Can you describe how data from p-XRF measurement can be used, say, in decision making for, say, setting the casing depth or maybe adjusting the target during drilling? Can you imagine such an instance?
Uh, how does I open this? Turn to before page. How can we use every alteration and all formations and alterations have their own chemicals. So if we can describe these ratios, we can easily construct our intervals. For example, how can I say? For example, third interval, it's 3250 to 3650 meters, basement, Felician marble. We saw fluctuation in calcium oxide levels confirm the presence of marble lenses. Actually, it means there fluctuations looks like few, but if we get a bigger scale, we can easily solve this. So also we check potassium oxide and aluminum oxide ratios. It's give us fillet and mica schist because potassium oxide ratios increase because of the mica schist, for example. Every lithology have own chemistry. Every alteration have own chemistry. If we can interpret this data easily, we can understand. Probably I couldn't answer enough because of my English. Sorry.
Yeah, that's fine. That's fine. Aside from, say, you have one example here of potassium aluminum elemental ratio that might indicate hydrothermal alteration. Are there on any other, say, other elemental ratios that are interesting in identifying hydrothermal alteration zones that
Yeah,
p-XRF can identify?
yeah. For example, alteration zones is our detachment fault zone is alteration zones. For example, in our detachment fault zone, we observe calcium oxide. It means probably after the main deformation, meteoritic origin water cross this place, so we can observe calcium oxide. Otherwise, heat if too high, it don't let calcium oxide don't let the calcium oxide increasing. How can I say? I don't know, but we know that our main alteration happened in 250 to 300 degrees, but after that it contaminates with meteoritic water because we saw calcium oxide spikes.
Okay, so this is after the loss zone, right? The calcium oxide spike.
Yes,
Yeah.
after the losses. Well,
Okay then. Another question here. How do you think can p-XRF differentiate between meteoric and magmatic fluid interference or influence rather on the rock?
how can determine differentiate what?
That's tough. Magmatic versus meteoric fluid influence.
Ah, it can't, but it just our estimation because we also have wellsite observation. p-XRF cannot explain everything. We should use also our wellsite observation.
Okay then. How do you think can p-XRF improve drilling efficiency um, or generate, say, time or cost savings during drilling or during exploration?
How can help the cost or time saving? It can help, for example, if we drill we think that we are very close to our targets, but our XRF data don't show any evidence for about alteration or hydrothermal activity. So it means we are going wrong way, or we already passed our target. So we can change during the drilling operation. We can change our target. For example, we use p-XRF for unsuccessful well operation. We cannot reach the reservoir. If we have this info before than or drilling operation, we can easily decide to, okay, stop, we don't need more drilling, more continue to drilling. We should stop, we can set it. So after that, start to sidetrack operation to other targets. So it's time saving and money saving for us. Also, sometimes you drill, but you can't observe anything. But if XRF data show us, yes, you close, very close to main reservoir, so we can drill, we continue to drill, we continue drilling operation. Otherwise, we can't, oh, okay, nothing is here, so we left the well. And this type can use this type decision.
Yeah,
And
well,
target and survey, give us target and survey deletions possible.
yeah. Okay, yeah, I can imagine how helpful high resolution data would be, say, in detecting perhaps transition zones between different lithological
Yeah,
layers.
yeah.
That would be
For
tough to detect.
example, yes, yeah. For example, illit and serisit amount give us temperature, give us information about temperature. When we getting close to our targets, if we solve illit and serisit ratios, we can understand, oh, it's still cool environment, or we are getting, we are going hotter place. It's actually very easy for
Okay, now we're getting more
interpretation.
questions, and let's try to go through them in 5 minutes. A bit equipment specific questions. I'm not sure if this is something you're able to answer, but what type of p-XRF did you use? How many elements can it detect? There's also a question here on detection limits, but I'm not sure you can. It's probably a number of different figures for different elements, but maybe like some specifics of
Uh,
the equipment you're using.
my faults, I don't put device photos, unfortunately, but maybe we can solve this game. It's Thermo, it's mobile testing stand, that's all. Sorry, I don't remember it. But we
Okay,
use nearly 100 sample for XRF
hmm.
analysis.
Okay. Someone's asking for a price. Like, can you estimate the price for it?
Yes, it's price imported things. I actually passed this part. For example, I can't exact number, but it's cheaper than the laboratory XRF exactly, because you give money for all days if you use portable XRF, but laboratory XRF needs money for every analysis operation. It creates important differences, really different. Also provides real-time data, so you can decide immediately. And you can affect the link survey when you want.
But I think the the notable thing is that it's cheaper than a lab XRF.
Lab-XRF, cheap, not cheap, especially in Turkey,
Really.
not cheap.
Okay.
Yes.
Okay, so maybe let's just do one last question before we wrap up. You mentioned that there
Okay.
is, I mean, there's a lot of knowledge that has to and experience that has to go to every interpretation of p-XRF data. So what kind of training, what kind of experience do you think should a well site geologist have before they can confidently interpret p-XRF data?
Can you repeat? Sorry, I can't understand.
Sorry, what kind of training or experience does a well site geologist need to have before they can confidently interpret p-XRF data?
How can train? You asked how can we train us for website geology and
Yeah, I
using
mean for
for
specifically
using
for using p-XRF, yes.
things. Actually, they should start to work study for alteration minerals as, is important there. Creating conditions, temperatures, which temperatures, which elements or minerals needs which temperature, for example, because you can estimate easily temperatures condition in the well. Also, which thermal activity creates some minerals you have to know. Everyone should learn geochemistry, basic geochemistry for this. Otherwise, we couldn't understand. So, for example, my geochemistry background is not good. So I try to use AI, Gemini or ChatGPT, but they are not enough, and they did sometimes important wrong decision.
Okay then, so it's geochemistry, knowledge of hydrothermal alteration, knowledge of perhaps the
Especially
lithology of the site you're
alteration
drilling in.
effects, yes.
Yeah, yeah, for
Alteration
sure.
conditions, alterations, products, we should know this. Otherwise, we can't interpret it.
Okay then, and I think on that note, it's very important to remember that the PXRF is a tool, but you also need to have the expertise to interpret the data.
Yes, yes, of course.
Yeah, of course. Okay then, so I think that wraps up our webinar. Thank you very much, Yetkin. That was a very good presentation. We'll have the recording of this up on our YouTube channel maybe in a week. So for those who might want to rewatch it or for those who missed some parts of it, it'll be there. Thank you for everyone who showed up. And Yetkin, thank you again for the presentation. Thank you for your time.
I
And
thank you for you.
to everyone, have a happy weekend. Goodbye. Thank you.